Hi, so in this video we're going to do this traffic signals effect you can see here. What we're going to do first of all, we'll create a blueprint to represent just one of these lamps and set up a material where we can say what colour that is and how bright the colour is. So you'll see one of the things we need to do to get this effect to work properly is have lights that don't just come onto an immediate full brightness, like they take a quarter of a second or so to reach full brightness. It can be any time period we want actually, that'll just be a variable. Once we've got the lamp blueprint, we can then arrange these in other blueprints to make whichever signals we want. So on the left here, we've got standard traffic lights, which goes red, red, amber, then to green. Then eventually it will go back to amber, then red. On the right here, we've got this this railway crossing style signal, which will be off for a period of time. And then eventually you have just an amber light come on down here in the bottom middle, and then it will go to these two flashing red lights at the top. And again, as you can see, we need an effect where the lights don't just come on to full brightness, but gradually fade on and fade back out again. So what I'll do, I'll pause the video here while I go and start a new Unreal project, and I'll see you then. Okay, so here we are with a new project based on first-person template. And what I want to do before we do anything else is just bring in the meshes that we can use to be the lamp and then the two different types of light housing that we've got. So I'll drag these FBX files into the content browser. For the one thing about these, we need to set this uniform scale to be 10, otherwise they will come in and be just too small. So we'll set uniform scale to 10, hit import all, and then I'll show you what these meshes actually are. So the first mesh we'll look at is this, just simple traffic light housing, such as you'd see in most countries, I think, but it's based on the UK model with this white trim around the outside. The other one is the railway crossing housing, and you'll notice that in both cases they've got these little openings where the lamps actually go. And that's what the third mesh is, lamp front. So this is just a little, it's like a slice of a front of a sphere, which is, we're going to have a material for this, which will be the next thing we'll do, where we can control what colour the material is and how brightly it's glowing. So, yeah, if you drag these into the world, you'll see they're just standard static meshes. So next thing then, let's right click to create a new material, and we'll call this lamp front material. Okay, and then what we want to do in here, if I just open that, we need this to be able to glow a given colour and a certain brightness. Now the way we can do that is by just interpolating between black, which will be no glow at all, and then the colour that we actually want, so red, amber, green. So first of all then we'll create a constant 3 vector to represent the light when it's off, so just this black colour. It will start off black and we don't need to change that. Then for the colour that we want it to, the light to actually be, we need to from blueprint later, because we can't set this in the material to any given colour because we don't yet know whether this is going to be red, amber, green, or any other colour light for that matter. So now we've got that in, we'll need to be able to interpolate between the two, so we want to linear interpolate. There we go, where A is the black colour, B is the colour we're going to go to. I'll change that to a different colour in a minute, and that will be our emissive. Now one other thing, we want this to be an unlit material, so if I just click in the background to get the material properties, and we've got shading model, we'll change that to unlit. So it glows with its own light, but doesn't get lit by anything else, basically. So here what we'll do, we'll click on our parameter that we made, our vector parameter. We'll rename this to color, and it can start with a default value of green, just so you can see what this is like. Okay, we'll wire the output from linear interpolate into emissive color now. And then for the alpha amount of the linear interpolate, which basically controls how we blend in between black and in this case green, we want another parameter so we can control that from blueprint. So if we right click, look for scalar parameter. Scalar parameter is just a single number, which is what we want here. I can't think of a very good name for this, so I'm just going to call it on-off amount, as I'll do. It's something I can remember, well, as long as I can remember that in blueprint later we'll be fine. And we'll wire that into alpha. And as you can see, when this parameter is set to 0, like it is now, that's 0 default value, the light is off. When it's 1, it's at full brightness, and other values will give us figures in between. I'm going to leave that on 0.1 for now. Okay, so we've got our parameter color, our parameter on off amount. That's really all the material needs to be. It's really not a complicated thing, so we can hit apply here and save, and then start setting up the lamp. So for an individual lamp then, we need to think about what different states it can be in. It can be either on, off, or it can be what I've called the cycling or flashing. We'll call it flashing state actually, as that's a little bit more descriptive of what it actually is. So to set this up then, before we make the lamp blueprint itself, we need to make a blueprint enumeration, which I'm going to call lamp state. There we go. And this will list the 3 states that a lamp can be in. So click new 3 times to get 3 states. And this can be on, or it can be off, or it can be flashing. And then what we'll do, we'll have a blueprint that can switch the lamp into any one of these 3 states as and when we need. So save that. Now we can work on the actual lamp blueprint itself. So right click in the content browser again, blueprint class, and it's going to be an actor. As it says here, an actor is anything replaced in the world, and that's what we want. So make an actor and call that just lamp or lamp blueprint, whichever you prefer. So then opening this, we can look at what kinds of components we need. Now really we need 2 things. We need that lamp front static mesh, that slightly curved mesh that I showed you before. That will have the material that we've just set up, so we'll do that first actually. So add component, static mesh. There we go. And I'm just going to drag this up to make it the default scene route, so we get rid of the the white sphere that was there already. For the mesh itself, it's lamp front, which as you can see there, that's that slightly curvy mesh that we had. And then the material this wants to use is the lamp material that we just set up, lamp front material. So that will be there, and it's got that default green color because that's just what we left it as. What this also needs is a point light. So as well as the emissive light that's lighting up this mesh itself, we'll have a point light that can cast light onto anything nearby. So we'll go add component again, look for point light, and this will be sort of in the wrong place and way too big. So I'm going to move this forward in Y a little bit. So after what, we'll put a value of 30 in the Y location, so it's just in front of the mesh. And we'll drop the attenuation down to something very small, like 25. So it will fit nicely inside those little openings that the lamps go into. And it'd be a waste if it was much bigger than this. It may actually cause problems too. Now the intensity, I'm going to default that to 0 because we're going to control that through Blueprint. So that's all that we need in terms of components. So I'm going to hit compile. The next thing we need to do is go over to the construction script and set up some variables for setting the color of this so that we can get it all to work. So in the construction script, we'll make, well, first of all, it's not really a parameter of the construction script, so we don't want it as a local variable, but as a variable of this blueprint, we have a variable called color, and the variable type that needs to be is linear color. So this is a variable you can store any color in, so red, green, blue, whatever. We want that to be editable, so you click the little eye icon over here to open that up, so that we can change this through the editor to be whichever color we want on a lamp by lamp basis. Now the first thing we need to do is grab hold of our static mesh, which remember is the little lamp mesh. You could have renamed this to lamp mesh if you wanted to, but there's only going to be one static mesh in this, so I think that's fine. And we want to set the value of the color parameter in the material, so this color parameter needs to be set to whichever color we're storing in this variable. So we'll go set vector parameter on materials, wire that in, and the parameter name, let's just double check. Yeah, we called this color, capital C. So that will need to be color, capital C again. And then for what value, I know it says XYZ here, but you can think of this as RGB rather than XYZ. What we're going to do is get our color variable, wire this in, and it will automatically put in the conversion from linear color to vector for us. So the next thing we need is the point light. That needs to change its color to match the same color. So I'll drag the point light in. Then there should be a set color, set light color, that's it. And then new light color can again just have our color parameter, color variable, wired into it. Like that. Okay, so just to see what that does, if we go back to the viewport, to the main editor window, drag one of these lamps in. You can see there the lamp mesh with the point light, and if I change the color thing to, you can see what I mean, how that will well, you can't really see the light showing up much, but you can see the mesh changing colour. The reason it's not changing colour much is because we've still got that alpha amount on 0.1, so it's not a very strong glow. But you can see what the effect of the construction script does, where anytime we change our colour variable now, it will update the material to match. I'm just going to default that back down to being a black colour again. As I say, the light, well, I turned the light's intensity all the way down to 0, didn't I? That's why we can't see that. Okay, so if we head back over to the lamp blueprint, we can now go over to the event graph and start wiring up like a timeline to get this to actually, switch on and off and flash. The things that are there already, I'm just going to delete. I'll bring these back in later if we need them. First of all, we're going to need a couple of variables. So we want a variable to say whether or not the light's flashing. So in the case of the railway light we saw, the red lights do flash, whereas in the case of traffic lights, they don't. They just come on. There are some countries where you would have flashing amber lights, I think. So you could just adjust what I do later on to get that effect if that's what you're after. But in any case, we need a new variable. I'm going to call this flashing with a question mark at the end, and that is a Boolean. Now what we also want is a float to represent how bright the light should get to. So when the light's coming on from being completely off, what's the maximum brightness it will eventually get to? So that's another variable. We'll call this light max intensity, and that will be a float. So a decimal number basically. We want to know how long does it take the lights to come on and off. For different lighting effects, you'll want these to come on and off at different speeds. So some lights will come on very, very quickly, like in 0.1 of a second. Some it might take a little while for them to warm up, depending on what you're trying to do. So we'll make another float, and I'm going to call this on-off time, as in how long does it take the light to actually go off from once it's been told to go off, or to come on for that matter. And that again can be a float. And then cycle time, or flashing time if you want to call it that. We'll call it flash time. Or flashing time. And that's going to be, if the light is meant to be flashing on and off like in the railway crossing sign, how long does it take it to go through one complete cycle of being on and off? So from off to full brightness, then back to off again in how many seconds? And I think that's all the variables we need for now, so I'll hit compile, just so that we can give these some default values. Now flashing can default to false, max intensity we'll go with 5000, and the on-off time I'm going to go with half a second, so 0.5. And for cycle time, I'm going to put 1 second. So it takes 1 second to go from, for flashing time, sorry, it takes 1 second to go from off all the way to on and then back off again. Hit compile. Now what we need is a timeline, which will have a curve in it to basically animate, if that's the right word, this light brightness. So we right click, we say add timeline. You can give this a new name, timelines. There's not going to be another timeline, so it doesn't really matter what it's called. I'll leave it at timeline 0 for now. We can rename it later if that makes sense too. Double click on this timeline to edit it. And if you've never used these timelines in Unreal before, basically it's a lot like keyframing. Before we can do anything, we need to add a track. So if you click this add float track button, like letter F at the top left, we basically get what is a timeline where we can set some values to animate. Now this can be the positions of objects, the brightness of lights, the value of any parameter basically, any variable. And what we want is just a 1 second timeline which goes from a value of 0 to a value of 1. Now at the moment we have a 5 second time. Up here length it says 5. Let's drop that to 1. So if you press enter it will automatically update what Unreal's doing. Let me just zoom back in again. So if you imagine the x-axis is time, so over the course of 1 second, the y-axis would be the value of some variable. So we want a value to start at 0 and move up to 1 over 1 second. So right-click anywhere in the timeline, press Add Key, right-click somewhere else, press Add Key, and then you can select these and type in where you actually want them to be. So we want our first key to be time 0, value 0. Our second key we want to be time 1, value 1. And instead of this being a straight line like this, we want to make this a little smoother, which you can easily do by right clicking on the keys and selecting auto. As you see there, it creates more of a smooth line. So the intensity of the light as it comes on and off will kind of follow this curve in terms of its brightness, increasing and decreasing if we're going backwards. That I think is all we need to do in here for now, so we can just hit compile, save there. and then using these tabs at the top, go back over to the event graph. Okay, so what do we want to happen here? So when this timeline plays, one thing we should have done is rename this. See how the track that we just set up is called new track 0? That's because I didn't rename it. So if we go back into the timeline tab up here, where it says new track 0, just right click there, hit rename, and we'll just call this something like light amount, or light intensity if you prefer. There, that's a little bit more descriptive than new track 0. So what do we want to do here? So as this value increases from 0 to 1, or decreases from 1 to 0, we want to go into the material that we set up and change this on-off amount to be whichever. So if you remember, 0 is completely off and 1 is completely on, and we'll sort of go through smoothly in between. So we're going to need to grab hold of the mesh again, the static mesh, put that there. This time we need to do a set scalar parameter in materials, not set vector parameter like we did in the construction script. And the name of the parameter, if I remember, was on-off intensity or on-off amount. On-off amount, yeah. The one I said I couldn't really think of a good name for, so it doesn't really matter as long as this is called the same thing in here. And what do we want to set it to? Well, we want to set it to whichever this light amount is. So remember, this is a value that's changing between 0 and 1, and this parameter value expects a value of 0 and 1 to drive that linear interpolate. The next thing we want to do is set our point light intensity to increase or decrease in exactly the same way. So we'll drag in the point light, and we'll do a set intensity there. And the intensity doesn't want to be just 0 or 1. Like an intensity of 1 would hardly show up at all. If it did show up at all, it would be very, very dim. So what we're going to do is take our light maximum intensity, which is the variable we set up earlier. We're then going to multiply that, so float multiply by float, with whichever amount is coming out of here. And it might have been a bit easier to see if I'd done those the other way around. Hold on. Yeah, that's a little bit tidier, but as long as all we're doing is taking our light maximum intensity and multiplying it by the 0 to 1 value that comes out of here. So as the timeline updates over the course of a second, the light's intensity will gradually increase up to maximum, 1 times the maximum, or decrease down to 0 times the maximum, i.e., 0 brightness. So that is set up. Now, another thing we need to do is what we want to do for. Okay, so if we want a light to go from off to on, we're going to hit play on this timeline, and that will get the value to go from 0 to 1. If we want the light to switch off, we're going to hit the reverse on this timeline, and that will cause the opposite to happen. It will go from 1 back down to 0 again. Now, in the event that we want the light to keep flashing, what we actually want to do is keep on going forwards and backwards through this timeline. Well, that's one way of doing it anyway. As in, we'll want to go like start off, go all the way up to on, then back down to off again, then back to on, for as long as we want the light to keep cycling, flashing between on and off. So the way we're going to do that, we have a pin here, an output pin, which asks what do you want to do when the timeline finishes playing. Well, what we'll do when we finish, we'll have a branch. And what that branch will do is check the value of this flashing boolean, true or false. And if it is true, that the light's meant to be flashing, what we're going to do is check, have we just gone forwards through the timeline or backwards, and then do the opposite, basically. So this direction pin very handily gives you that information. Like the timeline has finished playing, but did it go forwards or backwards? So what we'll do here is drag away from this direction, and if you search for switch, the first thing it will have is, and here you get forwards or backwards. So if flashing is true and the timeline has just finished playing forwards, we now want to play backwards. The easy way to do that, well, you can have like wires stretching all across the blueprint like this. I don't really like to make blueprints a mess of wires, so I'll show you something else you can do. When we added the timeline, you may not have noticed that Unreal actually added a component over here on the left to represent the timeline. And we can drag that into the blueprint itself and then use it like any other object. So here we can search for that reverse function and wire that up to forwards, and then also get the play function and wire that up to the backwards. So let's just think for a second about what this section is actually doing. If I just move it a little bit away from there, we're saying when the timeline finishes playing, if flashing is true, if we've just finished playing forwards, play backwards. If we've just finished playing backwards, play forwards, which is what this play repeating, going backwards and forwards, flashing on and off effect. The next thing we're going to want is a custom event. Well, yeah, custom event that can be called from outside of this blueprint to push these buttons for us. So play, reverse, because what we'll have eventually, if I just show you, we'll have another blueprint which say contains this mesh, and it will also have 3 of our lamp blueprint that we're working on now. And the blueprint, the sort of top level blueprint that contains this, will need to be able to go into the lamps and say, right, you need to switch on, you need to switch off, you need to be flashing on and off, for all 3 of the lights as needed. So to get that to work, we're going to add a custom event to our lamp. So add custom event, and we're going to call this change lamp state. And what this needs to do, we'll need an input parameter first of all, so we will need to pass to this event what state we want the lamp to be in, where state is these things that we set up on off flashing lamp state. So, oops, wrong one. So our variable doesn't need to be of type boolean, our input variable needs to be of type lamp state, which, as you know, can be on, off, or flashing. First thing we want to do is check what have we been passed. So we'll do a switch on, in this case, lamp state. And we can say, right, and you can see where this is going. If we've been passed on, do what? If we've been passed off, do what? If we've been passed flashing, do what? Well, what we want to do first of all then is set the value of this flashing variable. So our flashing boolean, in fact, we'll do these as on, off, and then flashing. So if we've been told to switch the light on, and we don't want it to be flashing, so flashing is set to false, then what we want to do is get our timeline, and we want it to play. So basically we want to do the equivalent of hitting this play button up here, but we want to set how fast it plays, because if you remember, we've got some variables over here. We've got a variable over here on off time to say how long the light should take to come on. So we could pass in, if this was set to a value of 2, we want it to take 2 seconds for the light to come fully on. If it was 5, we want it to take 5 seconds. So the way we're going to get this to work is we'll get our timeline, call the set play rate function, which controls how fast we go through the timeline, where 1 would go through at normal speed, so it would take 1 second, 0.5 would take 2 seconds, 0.25 would take 4 seconds, and higher values would go fast, so 2 would go through in half a second. So to go from our time in seconds to the rate that we want to divide 1 by our on-off time. So we want a float divided by float, and we want to do 1 divided by the on-off time variable that we set up, and that will be the play rate. So be careful this isn't set to 0, otherwise you'll try and do a divide by 0 and nothing work. That won't actually crash the engine, it's just that Blueprint is good enough at handling errors like that, it just won't do anything. So as long as on-off time is set to something good, so we've got here on-off time is 0.5, so the timeline will play at 1 divided by 0.5, so twice as fast, so it will take half a second to reach full brightness, which is what we want. And then all we need to do is tell the timeline to play, so we can go timeline play, and that will work. That will play the timeline through at the speed we want to bring the lights to full brightness. For off, it's basically the same thing, but we do a reverse at the end instead. So if I just move this around a bit, then go Control-C, Control-V to copy and paste. Off is exactly the same. We're not flashing. We want to take the same amount of time. It's just that instead of doing a play at the end, we want to tell the timeline to reverse. There, so we will play backwards and bring the intensity down from, maximum intensity all the way down to 0. The flashing case, let's just space this out. We didn't do a very good job of spacing this out in the beginning, it seems now. Oops, move this down here. For flashing, we do something slightly differently in that we first of all set the flashing boolean, so let's copy and paste that, and this time it is going to be true. So that will keep the light going on and off. It will basically set, we've seen up here, flashing is true, so this if statement will fire its true pin and we'll keep going backwards and forwards through the timeline, flashing the lights on and off. Now here, we want to do a similar thing to this. If I just copy and paste the float divided by float, except it's flashing time that we want to wire in there, and it's 2 divided by, because if you think about it, we want flashing time to be the amount of time it takes to go through the entire timeline twice, so to full brightness and then back again. So it's 2 divided by, not 1 divided by. And then we can copy this timeline 0 variable down. We still need to do the set play rate. I could have copied that down as well, thinking about it. So set play rate will be whatever we've worked out here. And then we want to tell the timeline to play. It wouldn't actually matter really. Well, if we started it with a reverse, would it make a difference? Or it depends whether it might not make a difference, but I'm going to go with play. Right, so that's really all this blueprint needs to be doing. We've got a timeline set up and then we've got the timeline set up so that it will change the on-off parameter in the material and the intensity of the light. We've got something set up here to handle what if we want the light to keep cycling through, getting brighter and dimmer by playing and reversing the timeline. And then we have a function here which we can call from outside of this blueprint to change the state of the light to on, off, or flashing and make whichever changes that needs over here. So if I hit compile on that blueprint, okay, I've forgotten to wire in a pin here, so I haven't wired in timeline 0 there, so that's what that complaint is. Now that's done, hit compile, all should be okay. We can save that, and what we'll do next is get on with making the actual set of traffic lights, which uses 3 of these lamps. Okay, so let's just set up the traffic lights housing blueprint then. Before we do that, similar to how we've got lamp state with on-off flashing, we need a similar enumeration for the traffic lights themselves. So blueprint enumeration, we'll call this traffic light state. And this is, what states can the traffic lights themselves be in. So for the ones we're making, they're based on the standard UK traffic lights. They can be in a red state, a red and amber together state, which I'm just going to call red amber. Then you've got green, and then finally you've got amber on its own. And we need to move in between these states on a certain timer so that it does the traffic light effect. With that done, let's just close some of the stuff I've got open. Okay, with that done, we'll create a new blueprint. It will be an actor blueprint, and I'm going to call this traffic lights. And then in here we need, first of all, a mesh. So again, add component, static mesh. No. Static mesh. And that's going to be the traffic lights itself. So we'll make that a default scene route. And I can't remember what I called that. Oh yeah, traffic light housing. That's the most, yeah, this one is what we want. And now what we need is 3 of our lamps in, and we can do those as child actors. So how that works is you go add component, child actor, and over here it will say what class is the child actor supposed to be. Well, it's going to be one of our lamps that we made. So let's change that. What do we call that? Just lamp. And you can see that's placed that in there. If we drag this up a bit, so we'll do the red light first. So I think that's up by 50 in Z. Then we can expand this child actor template area, and then we've got the variables that we just set up, so color, flashing, max intensity. Let's change this one to red. And you can see there that's got the red light in. Now if we actually we'll rename this first, otherwise it's going to get confusing. We'll call that red light, the child actor component I mean. Right click on that, hit duplicate, rename that one amber light, and we will move that down into the right place and change its color to be amber, which I think will go for red 0.1, green 0.8, and hit OK. And then we just need one more, don't we? So duplicate amber light, move that down to, actually rename it, green light, and that wants to be at minus 50 in Z. So that it sits in there. And yeah, again, we need to go in and change the color to be, I'll have that as full green, so no red, full green, no blue. Okay, so that's how we can really quickly reuse components as child actors to get different effects that we might want. Now, just for the blueprint in this, we need a similar thing. We don't need a timeline, but we do need a couple of functions and variables, events and variables. So over in the event graph, we don't need the begin overlap event. The begin player event we do need, so we'll do that first. So what we need to do is get these child actor components look after individual lamp blueprints, and we want to get hold of those blueprints and have them as variables over here. So the way that you do this, we'll drag in red light first, then we can do get child actor. Now what this will do is try and access the actual actor that this represents, but it will just give us it as a generic actor blueprint. We now need to do a cast on that to get our lamp blueprint from it, like so. And then from here we can just store that in a variable pretty easily by taking the as lamp pin and doing a promote to variable, and we'll just call that red. And then see over here on the left we've got a variable now called red, which represents our red lamp blueprint. We need to do a similar thing, so we'll just get amberlight to do the same thing. So amberlight get child component. Nope, get child actor, sorry. Get child actor. That will again need cast to lamp. And we'll store that in a variable in exactly the same way. So as lamp, promote to variable, and call that amber. And you'll see over on the left there in the variables there we've got another one. Now we've got red and amber over here. And then yeah, guess what? We need to do basically exactly the same thing for green. So drag the green light child actor component in, get the child actor that looks after, cast to our lamp blueprint, and then we'll promote that up to a variable. And then we've got like all three of our like sub lamps, if you think of it like that, as variables. So promote to variable, and I'm just going to call this one green. And because this is connected to begin play, this will happen as soon as the game starts running. Tick we will come back to, because we need the event that tick needs to itself use set up first. We're going to add a custom event, and this you can do with switching the state of the traffic lights to a different state. So where we want to go into the red state, we need to do things like switch on just the red light, switch off the other two. When we want to go to the green state, we need to switch on just the green light and switch off the other two. So we'll add this change traffic light state. Bit of a wordy name. You can put it something small if you want, change light state or just change lights. This needs to be passed like we did with the similar function in the lamp blueprint itself. We need to pass this state. And then this is of that traffic light state that we just set up. So red, red, amber, green, amber. We want to find out what state we've been passed. So switch on traffic light state. And then here's where we need to do which lamps do we need to switch on and off. So let's think about this. If we're going into the red state, we want the red light to be on. So if we grab hold of our red light, get red. Then we have a change lamp state. Remember this change lamp state that we set up, where we said we could pass that a value of on, off, or flashing. Well, if we're going into the traffic lights being red, red lamp is on. The amber lamp will be off. So we'll do a change lamp state on amber, and that can be off. And then obviously green. So if we're in our red state, green is off. Yep, change lamp state off, and then we can just do some copying and pasting, I guess, just to set up the others. So if we're in the red amber state, we copy these three, Control C, Control V. Red amber, as the name suggests, red light is on, amber light is on, green light is off. Paste again. If we're going into the green state, that will be red light is off, amber light is off, green light is on. Move this a bit down. Do a copy and paste of these three again. Done. So red light off, amber light on, green light off. So this can handle switching the lamps on and off as we go into different states. And you can see how, depending on what type of signaling you're trying to make, you could have as many different states and as many different lamps as you want and just switch them on and off accordingly. Now we need the tick function, because this is going to happen all automatically. So we're going to say, depending on which state we're in, wait a certain amount of time and then switch to a different state. The way I'm going to do this, we need a couple of variables to set, because most traffic lights won't have like each state lasting for 1 second. It'll be red for a certain amount of time, red amber for a very short amount of time, then green for quite a long time, amber for quite a short time, and then back to red for quite a while again. So we'll add some variables for that. So as a new variable, we'll call this red time, and that needs to be a float. We can then duplicate that with Control W and call this red amber time. Duplicate again, just call that green time. And duplicate again, and just call that amber time. And we'll set up some defaults for this. So before we can do that, we have to hit compile. Red time, I'm going to leave on 5 seconds. Red amber time is quite a short one, we'll leave that on 1 second. Green time, 5 seconds, just so we can, we're not waiting around for minutes for it to change. And then amber time can go back onto also 1 second. So what we have to do now is just get the tick function to basically switch through. We also need another float. If I just duplicate one of these again, just called timer. What timer is going to do is basically set, it's going to start from 0. Whenever we change state, time will go to 0 and then count up to one of these sort of time limits and then switch to the next state. So I think what we should do here, before we go into this switch, we should set timer back to 0. So we'll do a set timer, put that to 0. So whenever we go to change to a different state, the timer gets set back to 0, and then it will count up to whichever one of these times we want. Now what tick is going to do, first of all, it needs to check what state are we actually in. So I think what we're going to need to do here is make another variable, call that state, and the variable needs to be of type traffic light state. There we go. And again, we'll use this change light state function to set that variable. So we'll go state variable set state, wire that up here, and we can store the incoming state parameter in that, and then pass that on to there. Okay, so yeah, we say we want to change to a state. We set our state variable to be the new state that we want, set the timer back to 0, so that tick then down here, its first thing that tick does can say, well, first of all, it needs to add on to timer. So we'll get our timer and do a set. And what we want to set it to is whatever it is now plus the amount of time that's gone by, which is delta seconds. So tick, if you don't know, runs every frame, and delta seconds is the time that's gone by since the last frame. So we'll get hold of timer and do a plus on that. So float plus float, add how long has gone by since the last frame on, and store that result back in timer. So time will gradually counting up as frames go by. The next thing that tick needs to do is ask which state are we currently in. So we'll grab hold of the state variable, get that, and do another switch on state. So we're going to do different things depending on which state we're currently in. If we are, let's move down so we don't run into this other event. If we are in the red state, what we want to do is check with a branch, has timer reached red time yet? So do a branch, and the condition for the branch is going to be timer is greater than red time, which means in our case, it will mean we've been in the red state for, what was it, 5 seconds? Yeah. So if that is true, it's time to switch to the next state, which in our case will be red amber. So we'll call our change traffic light state and set that to be red amber. And then these are just very similar to that. So in all cases, we're going to need this, and this. Copy and paste that. If we're in the red amber state, if timer is now greater than red amber time, switch to the next state, which will be green. Then paste again. If we are in the green state and timer has reached green time, we need to go to the next state in line, which will be back to amber. And then the last one is if we are in the amber state. But let's just paste in another copy of all this. If we're in the amber state and the timer has reached amber time amount, go back to red. So this will keep us cycling through all 4 states. You calling this function as needed to switch the lamps on and off. And then one other thing we should do at the end of begin play, we need to say which state do we want to start in. So I'm going to do a change traffic light state and say go into the red state. Okay, so compile that, save, and let's see what happens. So if we take our traffic light blueprint, drag that into the level, rotate that so we can see from the start, and hit play. Yeah, see, so we start off in the red state, the red material on, and light there, we go to red amber for 1 second, go to green for what, 5 seconds I think it was, then switch back into just the amber, and then back into red for 5 seconds. And it will just keep on cycling through these for as long as you want. You can change the timing. I mean, this having 3-point lights might be a bit overkill for what this is. It's just a simple traffic light in a video game, so you could get away with just having the emissive material if you wanted, and not bother with the point lights and have it instantly switch and not have the kind of gradually coming on and going off effect. It's up to you, it depends what you're trying to make, but this is just a good way of showing how you can use timelines for this sort of thing, I guess. So the next thing we'll do, we will make a copy of this blueprint and use it to make the other type of signalling that I showed you, the railway, the railway crossing one. Okay, so we'll do the railway crossing lights, really just show how it can be quite flexible to have this system of child actors using the lamps, where you can reconfigure them to be any traffic signalling we want within reason. If you were going to have lots and lots of different traffic lights, railway crossing lights, and all sorts of different types in your game, you may not want to do what I'm about to do here, which is basically just copy the traffic lights blueprint and change a few things around. So the way I'm doing it is just a very quick way of going, what if we wanted to make railway lights in the first place, how would we have done it? If you actually wanted all these different types, like 10 different types of lights, you would want to think about having a base class, like a base blueprint with all the common functionality in, and then just change things in individual child blueprints, rather than having 10 unrelated copies of the same blueprint. But just for the sake of speed, that's what I'm going to do here. So we need to start off with another blueprint enumeration, and this is going to be what states can the traffic lights, the railway lights be in. So if I call that railway lights state, and these, if you remember from the beginning of the video, they can either be off, so all 3 lights off, or amber, just the amber light on, or they can have the red lights flashing. So this will make use of our flashing state on the lamps. I'll call that flashing red. With that done, and then here's just the really speedy, hacky way of doing this. We'll just duplicate the traffic lights blueprint, call that railway lights. It's actually the lights at a railway crossing, not anywhere else on the railway really. Right, so we'll come back to the event graph in a second, but first of all the viewport. Right, so instead of using this mesh, we would have used the other housing mesh that we brought in at the start, so the rail cross housing, that's this. And then the 3 lights will be laid out slightly differently. The amber light, that can just move down a little bit. If you've got the grid sensitivity set to 5, these should just move around quite nicely. I think 10 will be a little bit too much of a jump for them to fit in the gaps properly. So amber light moves down there. The red light, well, the one red light, well, we use the light that is already red. Let's just move that over a bit into there. That's minus 60 in X. The green light, I'm guessing that will be plus 60 in X then, and then just move up to the right amount. Yep. And that needs to change. So, well, they all might need to change. So let's look through them. So, amber light is the right color and it's got the right name. Red light, it's got the right color on, but we'll call it red light 1, because otherwise, we're going to have 2 of them. It could get confusing. The green light, we need to change its name to red light 2. And we also need to change the colour to be just a pure red again, so full red, no green, no blue. So this is what we would have done in the first place if we were trying to set up this style of lighting instead. With that done, what would we have done differently in the event graph? We will still promote these 3 lights, but they've just got different names. So red light 1 would promote as red 1. Amber light promotes as amber light, just the same, that's fine. Red light 2, we wouldn't promote and call it green, obviously, we'd call that red 2. This change traffic light state I will come back to in a second, because we need to change the function first. So this, and we're going to break a few things here, but first of all we'll rename this to change rail light state, and then here's where we get to break things. The parameter that's coming in needs to be of type railway light state instead, that union that we just set up. Then this variable also needs to change its type to be of railway light state. There we go. And then the switch statement won't be happy with that. We can delete that switch statement for now. Wire this back up like that. And then re-add the switch statement. So now we've changed the type of the variable. We'll do this. And this is what we would have done in the first place if we were doing this and not the traffic lights, of course. Now, as for the states, we've only got 3, so we can delete the 4th row because we don't need it. And now we just need to set up the whole kind of which lights are on, which lights are off, in which states. So the off state is fairly straightforward. All lights are off. So red 1 off, amber off, red 2 off. The amber state is how it sounds. Red off, amber on, red 2 off. Then flashing red is going to be red 1 is in its flashing state, amber is off, red 2 is also in its flashing state. Now at first these will flash together rather than alternately, but I'll come back to that afterwards. Now what is going on with tick? The timing bit is all fine. The switch is again complaining, so we'll delete the switch, re-add it as a switch on rail light state. And then what will be the fastest way to change all this? Okay, so if we delete the 4th state again, because we don't need it, we'll delete these 3 change rail light state. Actually, yeah, just delete those for now. They're just complaining. And then let's look at these variables. So if we use the top one for the off state, so we'll rename red time to off time. The middle state is what? Amber. So we've already got an amber time variable. So what would be the best thing to do? We'll get rid of red amber time and just delete the variable. No, not duplicate it. Delete it. Wire amber time into there. I'll change the default of amber time to be what should we have? It's 5 seconds. No, we'll leave it as 1 second actually. Then for this, so green time, if I rename that to flashing red time. And what will that have for a default value? 5 seconds, that's fine. So what's off time set to? Also 5 seconds. Okay, so let's wire these all back up. And then there's just when do we enter which states. So we've got our new change rail light state function. If we've just finished the off state, we need to go to the amber state. Copy and paste that down. If we've just finished the amber state, we would want to go to the flashing red state. And if we've just finished that, we want to cycle back to the off state. And you could, of course, have all this triggered on actions that the player is doing rather than, timing. So, player presses a button, it causes the lights to change. One of the things we will want at the end of begin play, we need to say which state we start in. Oh, that's fine. That's got the off state there, so let's compile that. There's no errors, quite surprising given all that. And let's see what we've got. So if we drop the rail lights in, move those up, and play. So we start off with the off state. I think that's 5 seconds, isn't it? We set it to. Then we have amber for 1 second. There we go. And then flashing red. And as I say, they flash together, not alternately, which is not how they actually work. But you see the point I was making. Like once you've got the child lamp actor set up, it's very easy to quickly rearrange different configurations of lights, different colors, different timing, and so forth. Now to deal with the way how they don't flash properly, well, they should flash alternately rather than together. What we can do back here, when we say that we enter the flashing red state, we want to put red 2 to the end of its timeline, so it starts playing from the back to front, if that makes sense, rather than playing from the start to the end. So what we'll do here for red 2, we'll get hold of that timeline, which we just left as timeline 0, if you remember, and then we can do a set to time. Oh, what is it called? Set playback position. That's it. No, set new time, sorry. Set new time. And if we set that to 1, it will basically jump it to the end of the timeline. So compile that, save. So this will start from the end of its timeline. Red 1 will start from the start of its timeline. And so they should flash alternately rather than together. I should have made that the state that we start in to make this faster, shouldn't I? But there you go, see. Sony can do effects like that. And really, by just rearranging these same lamps, you should be able to get any different type of traffic signaling you want within reason. You may have to extend the the lamp blueprint itself to do effects that we haven't covered here. Okay, so that's all I want to go through in this video. I hope that's been interesting, showing you how you can drive materials through Blueprint, how you can change lighting through Blueprint, how you can use timelines to do all that, and a little bit about how useful child actors can be at reusing things that can't really be done as actor components. Okay, so thanks for watching. If there's anything else you want me to go through with either Unreal, Unity, or any other bit of game development, please let me know and I'll see what I can do.